E.
Sir, are you speaking?
Yeah, sorry. Now you are able to hear? Mic was on mute. Sorry. Are you able to hear now? So half of cos inverse of A by B, if I call it as theta, that implies cos inverse of A by B, I can call it as 2 theta. Sorry. So which implies cos 2 theta is equal to A by B. Right? Now listen to this carefully, guys. If I take the LHS, if I have tan of 5 by 4 plus, what can I replace half of cos inverse A by B with? I can write it as theta, right? So what is tan of 5 by 4 plus theta? Ram, you can come here. Tan of 5 by 4 plus theta, what can I write it as? 1 plus tan theta by 1 plus tan theta by 1 minus tan theta, right? Then what do I do with this cos 2? What will you write that? So similarly, there is another term, right? Similarly, I have tan of 5 by 4 minus theta. It will be 1 minus tan theta by 1 plus tan theta. Is that right? Now, I need to add these two. When I add them, I get 1 plus tan theta by 1 minus tan theta plus 1 minus tan theta by 1 plus tan theta is equal to how much? 1 plus tan theta the whole square plus 1 minus tan theta the whole square divided by 1 minus tan square theta. Why is it so? A plus B into A minus B format. In the numerator, you have A plus B the whole square plus A minus B the whole square. What is it? A plus B the whole square plus A minus B the whole square. It is 2 into 2 times A square plus B square. So this will be equal to 2 times A square plus B square divided by, you already have A square minus B square. Have this as 2 and you can have this as 1. Now tell me one thing, guys. Cos 2 theta is A by B. But how can you write cos 2 theta in terms of tan? Is it not 1 minus tan square theta by 1 plus tan square theta? Correct, Ada? So cos 2 theta is equal to A by B. That's what they have given, no? If cos 2 theta is A by B, if 1 minus tan square by 1 plus tan square is A by B, then 1 plus tan square by 1 minus tan square will be b by a. So can I write this as 2 times b divided by a, and that is what we are asked to do. Does it make sense? Right? If you want to copy, please do it. Then, thank you so much. So those who are online, I hope you could understand. Right? At least know, let me know in the chat box. You're able to understand? I hope I'm audible now, right?
Yes, sir.
Okay. Shall we do the last problem? Can you try that? It's the same, huh? Okay. Just a minute. So we can start with the next chapter, right? The last one from your first volume, that is determinants. So tomorrow's test, I can ask, no? These kind of questions you will try. No positive approach. Positivity is different. If I ask only from properties, I have no questions to ask. You can finish the paper in 15 minutes. Otherwise, try பண்ண அட்லீஸ்ட் நான் பக்கத்துல உட்கார்ந்து வேணா ஹெல்ப் பண்ணேன். Okay. Right. So now shall we move on to determinants? Right. If you see, this is actually a combo chapter. Never someone will say you determinants as a separate chapter or matrix is a separate chapter. It is a combination of both. Like you need both those things to solve. But like when we discussed about matrices, right? We tried to understand why we are studying that first. Right? Why did we do that? To understand certain operations that can be done between numbers in a more systematic format. Is that what we are doing? Right. See, for example, if I have to talk about a computer science student, when you write the program for arrays, you write the for loops and all those things, where you will follow the concept of matrices. Right. Now the next point is you already have matrix to solve problems. Then why do we need determinants? Unnecessary complication. Right? Our life was easy previously itself. Why do we need this? Any idea? Why are we even studying this? Somewhere related to cross product. So maybe it is acting like a tool for you to solve. Okay, to some extent, yes, I can take it because I can say when you're doing cross product, you face the challenge of remembering such a big formula. Instead of it, you have something called as determinant. That is one thing. Okay, accepted. Any other use? So what he's saying is, most of you know how to calculate cross product. You would have learned in your 11th grade. At least in physics, you would have learned it. Where you will draw the determinant I cap, J cap, K cap, you write A vector, B vector, and then so on. Right? There we use determinants, okay. But by doing something called, see, when I do matrix multiplication, I get an output that has something to do with the data points that are given. When we discussed from the examples that we saw in the previous chapter, you would have seen that a person is wanting to buy these many number of books and these many number of pens. We try to assign certain variables. We know the cost of each book, we know the cost of each pen. Then we prepared a tabular column kind of stuff in the name of matrix, and we try to multiply them so that you get the final value. Is it right? So there is some purpose of it. In a similar way, if you look at this chapter, right? Last year in your 10th, okay, 2 years back, in your 10th grade, you would have learned linear equations in 2 variables. Similarly, if I have linear equations in 3 variables, similarly, I have linear equations. I can have linear equations in any number of variables that I want. But the only thing is, for me to find the answer, for me to find the solution. What do I mean by solution of a linear equation of 2 variables? That value of x and y, which will satisfy the equation. Okay, if I need a particular solution, what do I mean by particular solution? So generally, what is the linear equation standard format? Ax plus by plus c is equal to 0. If I give you this equation, okay, I've given you 2x plus 3y is equal to 5. Now I'm asking you, I'm giving you a challenge, say, tell me the exact solution of this equation. Will you be able to tell me? I put the question, you didn't listen to my question. I told you, tell me the exact solution of this. Means, I'm saying I need a particular solution. Will you be able to tell me why? Many solutions possible, and what was the mistake that I made? I would have asked you solution, which is called a general solution. Like how we told 1, 1 will satisfy, or some other number 0, 3 by 5, 5 by 3 might satisfy. Right? 5 by 2, 0 might satisfy. So these are all the ordered pairs, the set of ordered pairs that you're trying to write. If I have to relate it to sets, so coordinates are basically what are they? They are the set of ordered pairs which are x and y coordinates. Is it clear? So for me to make my question more stronger, to make it more accurate, what is the other data I need to give you? I gave you only one equation, but how many variables were there? So if you want to find the particular solution of a linear equation in 2 variables, the minimum number of equations that you need are, if I give you 2 equations, you will find them. Okay. Now I have another important question. By finding them, what am I doing? Representing geometrically. A point where the 2 lines are intersecting, provided their slopes are not equal. Is that right? So where they are intersecting is what is the particular solution of that particular equation. Right? So if you look at the back end, right, math is connecting so many chapters. You learn something called a linear equation in 2 variables. You learn something called as straight lines, but these two are related. So right, in linear equations in 2 variables in your 10th standard, if I have to tell you frankly, you learn the technique of how to solve them, but you never thought of why exactly you're learning it. Is that right? In a simpler way, if I give you a linear equation in 3 variables, okay, I ask you to solve it, then what is your expectation from me? I need to give you minimum of 3 equations, maximum I can give you anything. I'll give you 3 equations, ask you to solve them. So I'll be able to get the point of intersection of, or I'll get the common point. What do I call it as? Yes, I'll get x1, y1, z1 with respect to those 3 equations, which will satisfy all the 3 equations simultaneously. That's why we call them as simultaneous solutions. Is that right? Right. In a similar way, we know that if a linear equation is given to us, you can always represent that linear equation with the help of a matrix, especially with the help of matrix multiplication. When you do that, then there is a technique that was observed. I will not say this is something which is invented or something like you observe something and you framed a pattern. That is how these 2 chapters are actually formed. You're able to understand. So what exactly happens is if you look at the beginning of the chapter itself, they would have given you 2 linear equations. You will not understand why they gave you in the first place. Right? What exactly they're doing is, look at them. If I have one of the linear equations as a1x plus b1y is equal to c1, and I have other linear equation as A2x plus B2y plus is equal to C2. That technique you already know. If I ask you to solve them, what will you do? You will use elimination method, substitution method, you will use cross multiplication method, whatever you want, you are going to use. Is that right? But you are going to give me the same number or solution. Now you are learning an extra step of solving the same equation simultaneously with another tool called as determinants. So how are we going to do that? Observe it. So A1 is some variable, is a constant, which is multiplied to a variable x, right? So when you think of matrix multiplication, right? If I have to frame a question, if I give you a question, I give you two matrices, what is the first thing you check for multiplication to be satisfied? So you check the number of repeat. Correct yourself. What is the preliminary condition for you to do matrix multiplication? Number of columns of the first matrix should be equal to the number of rows of the second matrix. If that doesn't happen, you forget about matrix multiplication. Secondly, when you're doing the matrix multiplication, what kind of operation are you doing? Are you multiplying the rows with the corresponding columns or the vice versa? You multiply the rows with the corresponding columns. So now what we are going to do is, if I have an equation a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2, then what I will do is I will take a1 and b1 along the rows of a 2 cross 2 matrix and a2 comma b2 along the second row of the 2 cross 2 matrix, and I will make the variables as a column matrix, so that if I multiply these two, I'll get another column matrix called C1 and C2. What did we do here actually? What is the thing even we did? A given linear equation, you converted it into a form of matrix multiplication to give you an output. Does this make sense in the first place? Are you able to understand? Right? So here, this is a 2 cross 2 and this is a 2 cross 1 matrix where you got an output as 2 cross 1. So this is the reason. This is the first observation. We have not yet gone into determinants. So they understood the fact that by invention of matrix multiplication, they understood the fact that linear equations in 2 variables or 3 variables or 4 variables, whatever they are, can always be written in the form of matrix multiplication, so that the first matrix is always the coefficients of the variables. The second matrix is always the column matrix of the variables, which will give you the constant matrix. When you do this kind of a stuff, then you can use a tool called as determinant to find the value of x, y, z, or how many variables you have. So clear? That is the reason why determinants was even invented. I'm not saying invented again, I'm saying it's observation. For observation, you got some output, and that's what we are reading. So for determinants also, if there are 3 variables, you need 3. So the determinant is only a tool. It is not the deciding factor of how many equations are given. The deciding factor is linear equation in variables. So linear equation in dash variables. The dash should be the number of equations you need. 1 variable, 1 equation. 2 variables, 2 equations. That is the general rule of mathematics. Is that clear, guys? So using the same logic, if I give you a question like this, will you be able to think and write and tell me? So a1x plus b1y plus c1z is equal to d1. a2x plus b2y plus c2z is equal to d2. And a3x plus b3y plus c3z is equal to d3. Right? I want you to write a coefficient matrix multiplied with the variable matrix, which gives you the constant matrix. Coefficient a1, b1, c1. It's very simple. You can just borrow the idea from above problem. Adjoint method for solving the problem. Ax is equal to b. Hopefully the ax is equal to b. There's a reason. Okay. So basically, if somebody asks you why do we need determinants to solve simultaneous linear equations, that's it. So you cannot solve a quadratic equation, you can't. Only linear equations are going to be. Okay. So have you learned something called as cross multiplication method? For solving linear equations into variables, did you never? Okay, at least I tried to give you a hint. Let's see if you're able to recollect it. Yes. So you have 2x plus 3y is equal to 5. 3x plus 2y is equal to 7, for example. Then what you will do is you will write 3, 2. You write something like this, you remember? 3, 2, 5, 7, 2, 3, and again 3, 2. And you will write x, y, and 1 here. Have you ever seen this kind of a method? Cross multiplication for the picture. So x divided by what you're doing in the denominator, actually, you would have done something like this: 21 minus 10. You did it, no? That is actually, now you will understand it. 3, 2, 5, 7. What is it? It is actually the determinant of that matrix 3, 5, 2, 7. So at that point, they would have not told you. They would have told. That is why the name is cross multiplication. You will cross multiply and subtract the variables. So determinant mainly speaks about cross multiplying the variables in the matrix and get a particular number. That is why, if you see, when you deal with matrices, the output will be a matrix. Whereas when you deal with the determinant, the output will be a number. Right? So this is the basic logic. I hope you understood why we are studying. Now we'll proceed with what we are supposed to study. Okay. So if I have to define a determinant, so determinant is basically defined for whom? For a matrix. Because you need the systematic arrangement of those numbers. So determinant is defined for a matrix. Please write it down. To every square matrix, a term to be underlined. Every square matrix. Okay. Capital A, which is equal to Aij. So capital A is the name of the matrix, is equal to Aij of order n. We can associate a number. Just now I told you, remember, determinant will always give you a number. Order n means n cross n. We associate a number. That number can either be real or complex. Okay? We can associate with a number which can be real or complex called determinant of the matrix A. A determinant of square matrix A, where Aij is what generally? Small a you write, it is the name of the element. I represents the row and J represents the column number. So it represents the ith and the jth element of the matrix A. I hope you're able to understand this mathematical language, right? This is where an important point comes. First thing, whenever you want to define a determinant, what is the first thing that you need to have in your mind? The matrix should always be a square matrix. For a rectangular matrix of different order, you can never define determinant. That is the first point you need to make a note of. Secondly, now what you can say is, if at all I have a matrix A, which is given by ABC, right? A and D are on the first row and C and D are on the second row. Then if I put a modulus kind of symbol around it, okay, what am I doing? If I put a square bracket, then that is a notation for matrix. If I change the square bracket to a modulus, then that becomes the representation of determinant, which is written as det of A, or some books refer to it as delta A. Delta is also determinant. Okay, or you can also write it as, you will not read it as modulus of A, you will rather read it as determinant of A. That's where you need to be careful. If A is a number and you put two lines, you call modulus of that number. Whereas if A is a square matrix and you put that modulus, you read it as determinant of the modulus, determinant of the matrix. So why I am saying that you should not read it as modulus is because determinant need not be always positive, because read the statement carefully. They told it can be a number. That number can either be a positive number or a negative number. Don't get confused. Just because you are putting modulus, determinant should always be positive. You will get negative values also. Okay. So I hope that point is clear, no? So how you read this as determinant of A, never read it as modulus of A. Provided A is what? It's a matrix, right? Square matrix. Okay. delta over. Where this one? There is nothing like 0. So the determinant of a 0 matrix is 0. Okay. So they've given it in the note C. For a matrix A, delta of A is always read as determinant of A, and you should never read it as modulus of A. And secondly, I also told that point. What is it? Only square matrices will have determinants. So to make our life easy, okay, it is only direct determinant, it become complicated. So they wanted to introduce two more terms called as cofactors and minors. Okay. So based on that also you can define determinant. I'll come to that slowly. Have that in your mind. As of now, let's see first how to find a determinant for different types of square matrices. If I take a matrix of order 1, order 1 means only one element. So what is the determinant of that one element? The element itself. Determinant of a square matrix of order 1 is the element itself. Is it clear? That is the first point. So if A is equal to delta A, be a matrix of order 1, the determinant of A is defined equal to A, which is the element. It can be positive or negative. For example, if I ask you determinant of minus 2, minus 2, don't get confused with modulus again. No, determinant of a matrix is a number. Yes. That's what the statement says. Read the statement again. What is defined? Determinant of a square matrix is always associated with a number. Okay. Let A be a matrix of order 2 cross 2. So, yeah, where A11, A12, and A21 and A22 are the elements. Then how do you write the determinant of that A? You should always use the cross multiplication method and subtraction. That is how it is defined. Okay, as I told you, it is defined. There is no proof or something further. If you define it like that, maybe they got some answers and the theory worked. Okay. So if I take something like this, A11, A12, A21, and A22, if I want to define the determinant of it, so I hope you're able to understand. A is the matrix, delta is the determinant of this matrix. Then how do you write it? Multiply these two and multiply these two. Okay. So right to left cross multiplication should be written first. Left to right cross multiplication should be written first, and right to left should be written second with a minus sign. Okay. So it is A11, A22 minus A12, A21. It's a simple thing. This is already done. Right. So evaluate the determinant of 2, 4 minus 1, 2. 30 seconds, you can finish it. Make it fast. So you can do it in mind and tell what is the answer. 8 is the answer. So 2 into 2 minus 4. Minus of minus 4. So you get 8. Similarly, evaluate the determinant of x, x plus 1, x minus 1, and x. So you get x square minus of x square minus 1. So you get x square minus x square plus 1. So x square 1, answer is 1. I hope this I need not do, right? Now comes the next question of determinant of a matrix of order 3. Right? So what is it? So determinant of a matrix of order 3 is generally will generally take the help from the determinant of a 2 cross 2 matrix. Means certain numbers will be multiplied with the 2 cross 2 matrix which is obtained by leaving those numbers, or leaving the corresponding row and column of those numbers. I'll come to that point. So read the statement. I want you to read this because I'll tell you different ways of finding determinants. I'm not going to follow book method alone. I'll tell you how it's actually going to come. So determinant of a matrix of order 3. Order 3 can be determined by expressing it in terms of second order determinants. Have that in your mind. How? We'll see. Okay. This is known as expansion of determinant along a row or column. So there are 6 ways of expanding a determinant of order 3. So one is you can expand them along the first row, second row, or the third row, or you can expand them along the first column, second column, or the third column. Okay, I will directly start explaining. So they would have given a lot of theory. Shall I directly go with an example? Let's say A is a matrix of order 1, 2, 3, 3, 2, 1, 2, 1, 3. Then I want to find the determinant of this matrix. So determinant for delta A is equal to what? 1, 2, 3, 3, 2, 1, 2, 1, 3. Okay. So you can expand them along the rows, or you can expand them along the columns. First, I will do the famous method which everybody do. Okay. Generally, what will we do? We will do it along the row. So what will we do? You will take 1, which is this number, and what will we do generally? We will hide the corresponding row and the corresponding column, and you will be left out with determinant of 2, 1, 1, 3. Okay, is it right? Then what will you write? So you will generally have something like this. You will put a plus here, you will put a minus here, and you will put a plus here. Why we are putting that minus and plus, we will see slowly. But as of now, you know this. Correct? So minus 2 into determinant of, what should I do? I should hide the corresponding row and the corresponding column. So what is the matrix with which I am left out with? 3, 1, 2, 3. Then what should I write? I'll do one thing. I'll write it at the bottom so that you will get it in one line. I'll start it again. 1 into determinant of 2, 1, 1, 3 minus 2 into determinant of 3, 1, 2, 3 plus 3 into determinant of 3, 2, 2, 1. You will hide this column and this. So 3, 2, 2, 1 is what you're left out with. Any doubt in this? Right? So that is why they told expansion of the third order matrix is generally done by taking the determinant of second order. Okay. So 1 into, what can I write it as? So now you know how to multiply. So 6 minus 1. So it is going to be 5 minus 2 into 9 minus 2, which is going to be 7 plus 3 into 3 minus 4, which is going to give you minus 1. So 5 minus 14 minus 3. How much is it? Minus 12. So I told you, right, it is not necessary. Determinant will always be a positive value. It can be negative. Okay. So it is minus 12. That is the answer for this. So again, this is only a tool. What does that minus 12 represent? Nothing. It's just a number. It's just a number. That's it. Okay. So you can first make a note of this. Make it fast. So write it in this format. Don't do the method which you already write it in the format that I. Shall I proceed? Right. So in a similar way, if I have a 4 cross 4 matrix, if I have 5 cross 5 matrix, I can still find the determinant. Is it right? So when a 3 cross 3 matrix, a square matrix of order 3 is taking the help of the determinant of a 2 cross 2 matrix, then what will the square matrix of order 4 do? It will take the help of 3 cross 3. Of order 5 will take the help of 4 cross 4. So one number less, it keeps on going. Anyways, 4 cross 4 and all are not in our syllabus. Slowly, once you are able to understand that point, I'll explain it to you. Right. Now, shall we move on to the next? So I told you that they can be expanded along any row or any column, right? That I'll come to it slowly. Okay, before that, I want to explain. So properties of determinants is not there. Okay. So I wanted to explain two important terms. Then I'll go back. So I don't think that I went to 4.5 because there is something I'm going to connect it to the first part. Okay. Now we'll discuss the topics called as minors and cofactors. So please write down this. This is very, very important. Okay. So means what you're trying to do is, instead of looking at the determinant as a bigger thing, you're trying to break it into small chunks, for which you have something defined as minors and cofactors. So first, let's try to understand what a minor means. So you're given a square matrix of order n and h. Okay. Order n means, okay, let's say order 2. So how many elements are there? 4. Order 3. Order 4. So it keeps on going like that, right? So what will happen is, for each element in the matrix, there is something called as a minor that can be defined. So what does that minor define is, if you take a particular number, if you ignore the row and the column corresponding to that particular number, then you write the determinant of remaining numbers. I repeat it again. For a square matrix of any order, right? If you take a particular element and you hide the corresponding row and column of that particular element, then you will be left out with certain numbers, right? So that will also be a square matrix. So for that square matrix, if you are able to write the determinant, then that determinant is what is called as minor of the element for which you wrote. Okay. Now read the definition, you will understand. Minor of an element, that is how it is defined. It is not minor of a determinant. Minor is always defined only for an element from the matrix that you take. So minor of an element of a determinant is a determinant obtained by deleting its ith row, means the row to which that element corresponds to, and the jth column, means the column to which that element corresponds to, and write the determinant of the remaining matrix. That's called as minor, and it is represented with a symbol capital M, and there is a subscript that is associated with it. The subscript is the I and the j number of that particular element. If the first element, if it is belonging to the first row and the third column, you write it as minor of element 1, 3. So capital M represents minor. So minor is defined for whom? Only for an element. Determinant is defined for whom? For a square matrix. So these are all the points you need to understand. So please make a note of this. Minor of an element Aij of a determinant minor of an element Aij of a determinant is the determinant obtained by deleting its ith row and the jth column, in which element Aij lies. Ith row and the jth column in which the element Aij lies. Full stop. How is the minor of an element represented? Minor of an element Aij is represented as capital M with the subscript Ij. So minor of an element Aij is denoted by capital M Ij. Okay. There is a remark that is given. So the remark is minor of an element of a determinant of order. The minimum order is what? The minimum order for which you can define this. So you need a 2 cross 2 matrix for you to define something called as a minor. Because for 1 cross 1, what is the determinant? The determinant is a number itself. There is no concept of minor for it. So minor can never know, you should eliminate that number. So yeah, that is why the minimum number of elements that are required for you to define the minimum order of a square matrix for which you can define the minor is 2. Okay. Then if you see, then what will be the order of the matrix that you're obviously going to obtain? N minus 1. Right. So shall we try this with an example? Suppose I am covering this. Find the minor of element 6 in the determinant. So element 6 is here. So how do I find capital M? It belongs to which row? Second row and third column will be equal to cover this row and cover this column is equal to determinant of 1 to 7, 8. So what will be the answer? 8 minus 14, which is minus 6. So I hope this has got registered in your mind. So you can find the minor for anything. Okay. Just for the sake of practice, find the minor of all the 9 elements that are presented. Find the minor of all the 9 elements in the matrix given here. Guys, those who are online are able to understand?
Yes, sir.
So you need to find the minor of all the elements. So elements are 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is the minor of 1? Minor of 1 is 45 minus 48 minus 3, correct. Minor of 2, 36 minus 42 minus 6. Minor of 3, 32 minus 15, sorry, 32 minus 35 minus 3. So minor of 4, 18 minus 24 minus 6. Minor of 5, minor of 5. So 9 minus 21 minus 2. Sorry, minus 2, correct. No, minus 2. Minor of 6, we already found minus 6. Minor of 7. Is there anyone who needs help? Very good understand. Right. Minor of minor of 7 is 12 minus 15 minus 3. What is minor of 8? Minus 6. Minor of 9. 5 minus 8 minus 3. So I hope everybody got it. Including people who are online. I hope you got it. Yes or no? Yes. Okay. Now listen to this. The next important term after minor that we need to understand is cofactor. Okay. So cofactor is also defined only for an element. So what the cofactor of an element is? You will find minor. No? So to that minor, you need to multiply a number minus 1 to the power of I plus j, where I represents the row number and j represents the column number. So minus 1 to the power of I plus j, mij, is what is called as the cofactor, which is represented by the symbol capital A. It is not represented with symbol C, because C is taken for column. Another confused. R is for row, C is for column. So we use for cofactor, what do we use? Use capital A, Ij. So if it is only capital A, what is it? The row capital is like the matrix. So capital A with the subscript Ij is a cofactor. So capital Ij is equal to minus 1 raised to the power of I plus j times the minor of that particular element. Okay. Now you will be able to understand what is determinant. if these two things are clear. Right? Shall we try finding the cofactor of all the elements? Suppose I have this matrix 1, -2, 4, 3. Okay, I have 1, -2, 4 and 3, and I'm asking you to find the cofactor of each element. First, what will you do? Find the minor. To that minor, what is the prefix you need to multiply with? -1 raised to the power of I plus j. Do that fast. So what is M11? M11 is 3. M12 is 4. M21 is what? Second row first column is -2 and M22 is 1. I hope it is clear. Right. So if I want to write A11, then what should I write it with? Sorry? Listen to this carefully, guys. If I want the cofactor of the first element, -1 power 1 and 1. So 1 plus 1 will be 2. -1 the whole square times 3. Is that clear? So which is basically 3 only. What else? A12 is M12 multiplied to the prefix of. So I was about to write it. A12 is equal to -1 power. Here I is 1, j is 2. So 3 times the minor, that is 4. But I was asking about minor, you told me about cofactor. So I first wrote minor. So -4. A21 is how much? Minus of -2. -2. Minus of -2. -1 power 2 plus 1. It's okay, you can do mistakes, no problem. 2. அடுத்தது A22 என்னது? I hope you are clear with this. Right. Now, if I revisit the basic of what exactly a determinant means, do not find the definition here. What exactly a determinant means is, listen, A11, A12, A13, A21, A22, A23, A31, A32, A33. It is actually the element multiplied with the cofactor plus the other element multiplied with its corresponding cofactor plus the third element which is multiplied with the corresponding cofactor. This is the actual definition of determinant, which you'll find it in standard books. Now we are able to understand why you are putting that plus, minus, plus. That minus is actually borrowed from the cofactor. Correct? Here you put plus, here you put minus. Why? Because -1 raised to the power of 1 plus 2. Otherwise, you are getting a minus. Okay, that is -1 power 3. Here, -1 to the power of 1 plus 3, that is 4. So, otherwise, you are getting plus. So, like this, if you keep writing, no? So, if you keep writing it, actually the pattern will be like this: plus, minus, plus, minus, plus, minus, plus, minus, plus. This is the pattern. So with practice, right, when you do more problems, you can write the cofactor and minus faster. Because now what did we do? We had to show the steps. A11 is -1 to the power of, we need to process. No? Actually, what we could have done, plus, minus, plus, minus. Plus, minus, minus. Sorry, plus, minus, minus, plus. So plus, minus, minus, plus. Then what will you get? So the cofactor of 1 is 3. The cofactor of -2 is -4. The cofactor of -4 is +2. The cofactor of 3 is 1. So you can write it faster. Is it clear? So now did you understand the exact definition of what a determinant means? So this tells you that you take an element and multiply with the corresponding cofactor and the sum of all those factors. In a similar way, you can do for any element you want, but it should be corresponding either to a row or a column. You can do it along diagonal also. For example, I have A11 into cofactor of A11 plus A22 into cofactor of A22 plus A33 into cofactor of A33. This is also determinant. It will also give you the same number. Also, A33 is small. Right? This will also give you the same number. Now you're able to understand that is the reason why they mentioned that you can find the determinant by covering any row and any column, whichever you want you can do. That is why when we started with the standard method, we approached the first row. Not necessary always. If you're comfortable with columns, you can go with it. So logic is you take an element, that element should be multiplied with the cofactor of that element, and you need to add them. Clear? Am I clear, guys? So this is a major part. Apart from this, it's all about problem solving only. And the last exercise that we need to concentrate upon is inverse of a matrix. Now we'll go back to exercise 1 and start solving the problem. We'll come in the order. So properties we need not worry about. Okay. So though it is deleted, I'm not teaching because it is complicated and unnecessarily confusing. Had it been useful, I would have taught you. It's not useful for competitive exams also. So shall we proceed? Right? Yeah. So solve example number 3. Evaluate the determinant. For each problem, take only 2 minutes. Do it fast. Sir, minus 52. So there, what they did is they saw 2 zeros here and they expanded along column 3. But initially, I'll not suggest you to go with it. Go in the initial method that we do. Neato. So evaluate the determinant 1, 2, 4, minus 1, 3. So I hope everybody got minus 52. So second one, how are you supposed to do? See, with the logic that I told you now, I gave you a definition, an alternate definition for determinant, right? With that, can you use the logic and tell me what would the answer be even without solving? You need not solve that problem with the logic that I gave you. What did I tell you what determinant is? Element multiplied with its corresponding cofactor and added to them. So if you're taking a particular direction, you need to follow that. It can either be along row, column, or along diagonal also. So look at the diagonal elements. So what do you think will be the answer? Come out as a 0. But anyways, for the exam purpose, you need to solve it in row. So do it either along a row or a column. So I hope you're able to understand what I'm trying to say. So 0 into 0 plus sine square beta minus So first one is gone because sine square beta is multiplied with a 0. So you have minus sine alpha sine beta cos alpha minus sine alpha. One minute. So 0 into 0 plus sine square beta minus sine alpha into 0 minus sine beta cos alpha minus cos alpha into sine alpha sine beta. So minus of minus plus, so this and this will get cancelled. Answer is 0. Right. Example number 5. Find the value of x for which determinant of 3x x1 is equal to 3241. They are not matrices. Don't compare x. Don't compare on both sides and say x is equal to 2 or 4. Don't do that mistake. So 3 minus x square is equal to 3 minus 8. Cancel it. X square is equal to 8. X will be equal to plus or minus 2 root 2. Root 8 is 2 root 2. 2 into determinant of A. No. Because when you multiply 2 with the matrix, right, what will happen? The 2 will get multiplied with every term. So when you're cross multiplying, see for example, I have 1, 1, 1, 1. When you write 2 times 1, 1, 1, 1, what will happen? 2, 2, 2, 2. When you multiply, cross multiply, what will happen to the elements? 2 will get multiplied with 2. So it becomes 2 square. So it is actually determinant of 2a is actually equal to 2 power n times determinant of a, where n is the order of the matrix. So I hope you can do 4.1 faster. Do it fast. 2, 4 minus 5 minus 1. I'll write it here itself. Minus 2 plus 20, which is 18. Similarly, the next one, cos square theta plus sin square theta. Cos square theta plus sin square theta. What will get 1? What about the second one? So second one is x square minus x plus 1 into x plus 1 minus x minus 1 into x plus 1. So what will happen? You can take out that x plus 1 common first. Don't be in a hurry to multiply. Take that x plus 1 common outside. So we have x square minus x plus 1 minus x plus 1. So 1 and 1 will get cancelled. X plus 1 into x square minus 2x. So take out that x outside and then multiply. Or else you can multiply both the terms, you will get 4 terms. Is it clear? Right? So I want everybody to make a note of an important observation. Determinant of k times a, where a is a square matrix of order n. Determinant of k times a is equal to k power n times determinant of a, where n is what? Order of the matrix. But are you guys able to understand why it is getting multiplied n times? No? Yes. I gave you the property, but what is the logic? How do we know that it gets multiplied n times? It's simple. Listen. If I have a square matrix of values 1, 2, 3, 4, what is the determinant of this? So minus 2. Okay. So this is A. If suppose I make this as 3 times A, then what will happen to it? The 3 will get multiplied with every element in the matrix. So 3, 6, 9 and 12. So when you multiply this, what will I get? 3 into 12 minus 9 into 6. But most importantly, can I write this as 3 into 4 minus 3 into 3 into 3 into 2. So what I will do is I will look at the number of 3's that are common. So I can take out 3 square outside. Then what am I left out with? 4 minus 6. How did you get this minus 2? Because of 4 minus 6. So what is 4 minus 6? It is actually the determinant of A. And this 4 minus 6 will also be determinant of A. So why is it getting squared? Is because when you multiply a number in a matrix, the same number gets multiplied to the opposite values, to the numbers along the diagram. So when you multiply this 3 with this 3, what are you actually getting? You're getting 3 square. And where does the 2 come from? From the order of that matrix. For example, if it was a 3 cross 3 matrix, that 3 will get multiplied 3 times. That is why you will get 3 cube times the determinant of that matrix. So from this, we can generalize the formula that determinant of, so this is a very important one where I've seen people getting confused. Determinant of k times a square matrix A is equal to k power n times the square matrix A, where n is the order of the matrix. I hope I'm clear, right? So those who are online, are you clear?
Yes, sir.
All the square matrix. Are you getting a 0 for another problem also? Because I gave you one logic. What did I tell you? Element multiplied with the cofactor of it. That can be taken along the diagonal also. So all the elements are 0. Whatever is a cofactor, 0. That is what property says. If one row or one column completely is 0, the determinant of the matrix is always 0. Is that clear? So this is all for today. Okay, we'll do some more problems tomorrow, and then see that inverse we can discuss it next week also. Not a big deal. Maximum 2 to 3 more classes we are done with this time. Tomorrow you have test. Tomorrow. 6 to 7. 6 to 7 then you have 6 to 7. 1.5 hours. 40. Those who are online, we can find them. Thank you.